So in this section, we will discuss about implicit differentiation. So up until now, what we have done is we have found derivatives of function which are of the form y equals to f of x. Now, what we will do, not all functions are always of this particular format. So today we will talk about when a function is given in an implicit form. For example, let's say we have xy is equals to 1. So this is given in an implicit form. Then we need to find out the derivative with respect to x. So that will be, we take the derivative with respect to x on both sides. So derivative of 1, so that's a constant. This will be equals to 0. Now here we have the product of two functions, x and y. So we will use the product rule. So we have x multiplied to derivative of y with respect to x plus y times derivative of x with respect to x. So this will be equals to 0. So we have x times dy over dx plus y derivative of x with respect to x, so that is 1. So this is equals to 0. So what we have done here is implicit differentiation. So let's work on few more problems, and that will help us understand what is implicit differentiation and how to work our way around it. So let's consider the example. So let's say we have x raised to the power of 7 plus y raised to the power of 4. So we need to find out its derivative with respect to x. So first and foremost, we'll separate the differentials. We have ddx of x raised to the power of 7 plus ddx of y raised to the power of 4. So as usual, we can apply the power rule. So we have 7 times x raised to the power of 7 minus 1. So that will be 6 plus, now we have derivative of y raised to the power of 4 with respect to x. So what we will do here, we'll apply the chain rule. So if we assume that y is equivalent to x, so that means this is x raised to the power of 4. So we can apply the power rule to get 4 times y raised to the power of 4 minus 1, which is 3. But since y is not actually x, so we need to multiply it to the derivative of y. So we get dy over dx. So this is the final answer, and this is an implicit differentiation of a given function x raised to the power of 7 plus y raised to the power of 4. Let's consider another example. So let's say we have 5x raised to the power of 4 times y raised to the power of 7. We need to find its derivative with respect to x. So this can be written as 5 times derivative with respect to x. So what we have done, 5 is a constant, so we had pulled it out of the differentiation, and we are only going to differentiate the product x raised to the power of 4 times y raised to the power of 7 using the product rule. So we can treat x raised to the power of 4 as the first function and y raised to the power of 7 as the second function. So this will be equals to 5 times, so we have the first function multiplied to derivative with respect to x of the second function, which is y raised to the power of 7. Plus the second function y raised to the power of 7 times derivative with respect to x of our first function x raised to the power of 4. So this will be equals to 5 times, we have x raised to the power of 4 multiplied to, so we need to find out the derivative of y raised to the power of 7. Like the previous problem, we are going to use the chain rule. So we have 7 times y raised to the power of 7 minus 1, so this is 6. So this is the power rule, and this will be multiplied to the derivative with respect to x of y plus y raised to the power of 7 multiplied to derivative with respect to x of x raised to the power of 4. So this is 4x cubed. So this gives us finally, so we'll distribute 5 to each of the terms. So we have 35 x raised to the power of 4 times y raised to the power of 6 times dy over dx plus 5 times 4 will be 20. So we have 20x cubed times y raised to the power of 7. So this is the implicit differentiation of a given function. Let's try one more problem. So we have cosine of x cubed y squared. So let's find the derivative with respect to x. So here again, we have to first apply the chain rule. So we'll treat x cubed y squared as the function, as the variable x. Then in that case, differentiation of the cosine function will simply give us the negative sine function. So we have negative sine of x cubed y squared. So this will be multiplied to the derivative with respect to x of our assumed value, which is x cubed y squared. So we will use the product rule. So we have negative sine of x cubed y squared. So this will be x cubed times derivative with respect to x of y squared plus y squared times derivative with respect to x of x cubed. So this is negative sine of x cubed y squared times, so we have x cubed, derivative of y squared will be 2y times dy over dx plus y squared times derivative of x cubed will be 3x squared. So this is the implicit differentiation of our function cosine of x cubed y squared. Let's go to problem number 2. So here we have the implicit function x cubed y raised to the power of 4 plus 8x squared y plus x cubed minus y cubed equals to 7. So we need to find out derivative of y with respect to x. So we begin by considering the given function. Now we are going to differentiate both sides with respect to x. So we have ddx of. So now let's separate the differentials on the left hand side. So we have and differentiation of the constant 7, that will be 0. Now what we'll do, we'll apply the product rule to our first derivative. So this will be x cubed times derivative with respect to x of y raised to the power of 4 plus y raised to the power of 4 times derivative with respect to x of x cubed plus 8 times, again we apply the product rule to our second derivative. So that will be x squared times derivative of y with respect to x. So we also have to multiply with this factor 8. So we have 8 times y times derivative with respect to x of x squared plus derivative with respect to x of x cubed. So this is simply 3x squared minus derivative with respect to x of y cubed. So here we'll apply the chain rule. So this will be 3y squared times dy over dx. This is equals to 0. And let's complete all the remaining differentials. So we have x cubed times y raised to the power of 4. So that would be 4y cubed times dy over dx. Plus differentiation of x cubed will be 3x squared y raised to the power of 4 plus 8x squared times dy over dx plus 8. We have differentiation of x squared, so that will be 2x. So 8 times 2 will give us 16xy plus 3x squared minus 3y squared times dy over dx. So this is equals to 0. So let's now separate all the dy over dx together. So we have 4x cubed y cubed from the first term. Then from the third term we have 8x squared, and from the last term we have negative 3y squared multiplied to dy over dx, and we take all the remaining terms to the right hand side. So we'll take minus common. So we have 3x squared y4, the second term. The fourth term will be positive 16xy, and the fifth term is positive 3x squared. Now finally, we can isolate dy over dx, and that should give us. So this is the implicit differentiation of a given implicit function. So in this problem, we need to prove the power rule for rational exponents y raised to the power of n equals to x raised to the power of n using implicit differentiation. So let us begin. So we have y raised to the power of n equals to x raised to the power of m. So let's differentiate both sides with respect to x. So we have ddx of y raised to the power of n. This is equals to derivative with respect to x of x raised to the power of m. Now what we can do, we can apply the power rule to both the two derivatives. So for the first derivative on the left hand side, we have n times y raised to the power of n minus 1 times, so we have to apply the chain rule. Here we have assumed that y is behaving like x, so this will be multiplied to derivative of y with respect to x equals to, applying the power rule to the derivative on the right hand side, we have mx raised to the power of m minus 1. So dy over dx, so this equals to m over n times x raised to the power of m minus 1 divided by y raised to the power of n minus 1. Now, from here, we have y raised to the power of n equals to x raised to the power of n. So we can isolate y, so this y will be equals to x raised to the power of m raised to the power of n. So what we'll do, in place of y, we'll replace it with x raised to the power of m raised to the power of n. So our derivative of y with respect to x now becomes m over n times, we have x raised to the power of m minus 1 whole divided by, so we have y, this time it will be x raised to the power of m over n and whole raised to the power of n minus 1. So this is equals to m over n times x raised to the power of m minus 1 divided by x raised to the power of, so we'll multiply the exponents, so this will become m minus m over n. Now using the law of exponents, we can combine the two x from present in the both numerator and the denominator as x raised to the power of m minus 1 minus m plus m over n. So the m and m gets away, and this leaves us with m over n times x raised to the power of m over n minus 1. Now, we have y equals to x raised to the power of m raised to m over n. So if we use the power rule here, then this gives us dy over dx. So we have m over n times x raised to the power of m over n minus 1. So this is exactly what we have obtained using implicit differentiation. So in this problem, we need to obtain the equation of the tangent line to the curve at 1, 1. So we've already discussed about tangent line equation in the previous lecture. So here we will use the implicit differentiation to obtain the equation of the tangent line. All we have to do first is to obtain dy over dx, that means derivative of y with respect to x. So we have x squared minus 3xy plus y squared equals to negative 1. Let's take the derivative on both sides. So we have differentiation with respect to x of x squared minus 3 times differentiation with respect to x of xy plus differentiation with respect to x of y squared. So this is equals to the derivative of negative 1 with respect to x, so that is 0. Derivative of x squared is simply 2x minus 3 times, now we have to take the product rule, so we have x times derivative of y with respect to x plus y times derivative of x with respect to x plus derivative of y squared, so we'll treat y as x, so derivative of x squared, so that's simply 2y times dy over dx. So here we have applied the chain rule. So this gives us, so let's combine all the dy over dx terms together. 2y minus 3x times dy over dx, and this is equals to 3y minus 2x. So dy over dx, this is equals to 3y minus 2x divided by 2y minus 3x. So this is the slope of the tangent line. Now what we want to do, we want to obtain the slope at this particular point 1, 1. So we have dy over dx. So we will use a vertical line and use this particular notation. This means we are calculating the slope dy over dx at this point 1, 1. So this is simply, so we have this equation, in place of x and y we use the value, so 3 times 1 minus 2 times 1 divided by 2 times 1 minus 3 times 1. So this gives us, so 3 minus 2 will be positive 1 and 2 minus 3 is negative 1. So this is the slope. And finally, to find out the equation of the tangent line, we'll use the slope point form, which is y minus y1 equals to the slope multiplied to x minus x1. So at the point 1 comma 1, so our equation will be y minus 1 equals to, the slope is negative 1 multiplied to x minus 1, or simply put, this is x plus y equals to 2. So this is going to be the equation of the tangent line at the point 1 comma 1. So we need to find the slope of the tangent line to the circle at point square root of 5 comma 2, which is centered at the origin and radius of 3 units. So that means we here have a circle of radius 3 and it is centered at the origin. So this is our circle, so with radius 3. Now here we need to find, so let's suppose that our point square root of 5 comma 2 lies somewhere on the circle. This is a point P. So if we draw a tangent to this circle, so we need to find the slope of this particular tangent line. Right. So for that we will need the equation of the circle. So when we have a circle whose center is at the origin, then its equation is given by x squared plus y squared equals to the radius squared. Now what we'll do, we'll take the derivative with respect to x on both sides. So we have derivative with respect to x of x squared plus y squared equals to 0. 3 squared is a constant, so derivative with respect to x is 0. So we have derivative with respect to x of x squared plus derivative with respect to x of y squared. So this is equals to 0. So derivative of x squared is simply 2x plus derivative of y squared, so that will be 2y times dy over dx. So here we have performed the implicit differentiation. So this is equals to 0. So solving for dy over dx, so this is equals to negative x over y. Now at the point we need to find, so this is the value of the slope. So at the point square root of 5 comma 2, so we have negative, so we have negative x over y, so the x value is square root of 5 divided by y, so y is 2. So this is approximately negative 1.12, and this is the final answer.